Hello, everyone. We are going to start because we have already more than 50 persons in the room, and I will start with the introduction. I am Secretary General of the FIB, and I will tell you how this will go. We'll do some presentations about conceptual design. I would like just to say that the FIB is organizing many events. Among them, they're organizing a symposium every year and a congress every 4 years. But besides that, also organizes some other events specialized in several topics, like one every 2 years about sustainability. That will be next year. And also it has started a new concept of events, that is the Conceptual Design Symposia that started last year in Madrid, organized by Hugo Corres, and then is going to have another event next year organized in Switzerland, and two presenters, Aurelio Mutoni and Joseph Schwartz, will tell you a little bit more about that. And I also would like, just not to talk too much, say you that we are organizing also lately, because of circumstances that we are, webinars, and we are organizing quite a lot of webinars, many helped by young members of FIB, and this is one of those webinars that will serve as introduction also to the Conceptual Design Symposium. So something important also is that we record these webinars, and then we post the recordings in the FIB YouTube channel. So if you want to see some of the webinars or even this webinar, it will be in the YouTube channel. You can register to that channel, and then you'll receive all the news about that. And saying that, I will pass the word to Aurelio Mutoni and Joseph Schwartz. Aurelio is a professor of concrete structure at the EPFL in Lausanne, and Joseph Schwartz is a professor in the architecture school in Zurich, in the ETH in Zurich. Both are designers and are very much involved in conceptual design of structures, both civil engineer and buildings. So please, Aurelio, the floor is yours.
Thank you very much, David, for the introduction, and good afternoon, everyone, or good morning, depending where you are. So as already been said, I'm Aurelio Mutoni in Lausanne, Switzerland, and as already said by David Fernandez, FIB, the Federation of Structural Concrete, has started the last year a series of symposia on conceptual design. So the first one was in Madrid last year. It was organized by Hugo Corres and co-workers, and it was a very successful event, in fact, devoted to people in practice, but also to young and mainly also to young colleagues who are starting working in practice. And it is now the intention of FIB to continue this tradition, which was very successful, and to hold this symposia on conceptual design of structures every 2 years. And for this reason, we have decided, together with my colleague in Zurich, Joseph Schwartz, and our young co-workers, Miguel Fernandez Ruiz, Pierluigi D'Acunto, and Ole Olbrecht, to organize the next symposium in Switzerland. The idea is to do it in this old paper factory, also to have an interesting, for different reasons. The first one is because we think that it will be a fantastic atmosphere for the participants, and also because one potential discussion theme would be the reuse of existing structures, how to reuse this kind of existing structures. So the our idea of the next symposium would, well, the four themes the four topics that we would like to discuss. First of all, the role of the structure in the architecture, which is a very important topic, of course. Then we want to discuss and we want to present interesting, new, innovative structures. Another topic will be the history of structural design and mainly of structures. We are really convinced that we need to know better the history of structure in order to design better ones. And the last topic will be the role of the structural engineers in today's practice. So these are the four topics that we want to discuss in the next symposium. And the idea of today's webinar, in fact, is to introduce the next symposium, to show a little bit the spirit of the next symposium. It is always difficult to explain to people exactly what we mean with conceptual design. And we came to the conclusion that the best is to show examples of conceptual design. And this is the main goal of today's webinar. So if we are interested in the next symposium, please visit our website. And we will present the next symposium a little bit better also again at the end of this webinar. So I think that's all for the moment. I suggest that we start with the presentation by Hugo Corres, who was the initiator of this series of conceptual design seminars and who organized the symposium last year.
Just a small introduction about Hugo. He's a professor of structures in the Polytechnic University of Madrid. He's also a designer of a company in Madrid, and he is very involved in FIB. He's honorary president of the FIB and member of the Presidium. So I would ask, please, Hugo, you can share your screen.
Good morning, good afternoon, good evening, everyone. I am very happy to be here to share with you some conceptual design ideas. Yes, I am professor, but I feel really a designer. I like to design. This is very important, and I like also to teach a little bit about that. I would like to start my presentation. I will make or present several examples, or some examples, with at the beginning some introduction. I would like to start my presentation with this slide. When we organized the last conceptual design symposium, we decided to ask the participants to give a definition of conceptual design. We had many definitions, more than 60, and it is very interesting to read carefully the definitions, but all of them give a big and important role in conceptual design to creativity. So creativity is very important in conceptual design, but not only, and I will try to demonstrate that. Many years ago, I started to ask if engineers could be creative, or if we were creative, if we had good examples of creativity in our history, and if we had been educated in a creative environment. But it is clear that for the moment, everyone is able to assume that these people are creative. Picasso and some other Spanish creative people. But we had in our history very good engineers. They were very creative, and they were creating a good school to be followed. And so I hope that in the future we can put all these people together, because they really are creating things. So are engineers creative? Of course, yes. Can engineers be creative? Of course. We create everything, we solve a problem, but most probably we don't realize we are creating. This is a pity, but in many occasions is the truth. Do we have good examples of creativity in our history? Very good. Unfortunately, we don't know our history. Nevertheless, we had very good examples, and have been educated. Have we been educated in creative environment? Not at all. At least it was my case. We need to do something to change that situation. So when we started to organize our symposium, we tried to identify different steps in the conceptual design process, and we identify all these 4 activities or steps. And here you have a flow chart in which we prepared for our Model Code 2020. We, as you can see, we combine this flow chart, which has more than 10 years, and we combine this flow chart with these steps. So we need inspirations, we need knowledge, we need experience. You improve with your experience. And so inspiration is a very important part of our capacity to create ideas. Then you need to really identify and define the problem to be solved. And this is not always well done. And I think it is very important to be aware that we need to spend a lot of time on that. I will talk on that a little bit more later. And then you start the process of the definition of a solution to a given problem. And this is the more creative part of our activity. And finally, you need to formalize all these findings in a good way. So my first example is this logo. This was the logo we created for the first symposium of conceptual design. We had a good team. You see all very young people. We had good inspirations because this is a very interesting and nice structures designed by Torroja in the south of Spain. And we wanted really to show that to create an idea, you need to go step by step, and you are building the new solution of a problem in different steps is not the result of one idea in one night. This is absolutely the contrary. You need to work hard. And this is another thing we wanted really to show in our logo. And well, we started working, and you see that you start with some image which is not completely finished, and then later you step by step go to completing that image, and then you need to work a little bit more to make feasible the idea, and finally you have to build and you have to maintain the structure, and you have to see your result along the service life of the structure. This was the idea, and I think it was a good example of conceptual design. We had a problem to solve, and we were making different proposals, and finally we adopted, or we developed more in detail this one. So this is a good example. You will see that I personally follow the same process for our structures. So this is a second example. It's interesting. It's a sculpture which was designed by Cristina Iglesias. She's a very well-known artist from Spain, and it was installed in Foster Foundation in Madrid. And yes, it is, for me, one of the most interesting things of this project was to collaborate with a lot of different people, with different cultures, with different ways of doing things, but we were doing more or less the same. We were using more or less the same process, and we started. I started this work close to this model. This model was in the office of in one of the offices of the Foster Foundation, and you see that. And the problem was that this is the building. This one is the building of the Foster Foundation, and here they wanted to build a glass building. And Madrid is a sunny day, a sunny city, and so here you have the new building, the glass new building, and they decided to have some element to give shadow, and Cristina was invited to do this sculpture, and I started this process with this picture, which was sent by Cristina to me. She wanted to show me that she wanted to see the elements of the sculpture flying in the sky. It was not possible, but and our first idea was to identify the first ideas. And so you see that here you have the first sketches, some planes in which we will install a cable system to hang the panels, and we needed some bottom cable to stabilize the assemble due to wind loads, and we need a catenary cable to hang and to support the elements. And so this was the first idea. Inspirations are the previous work, and if you have some previous experience, is very important. It's another scale, but you always have the possibility to learn from that. And I think it is very important to identify as much as possible all the different aspects of the problem you have to solve. We needed to find a way to build the panels with the light material, because we wanted to minimize the weight of the panels. We needed to create a cable net, and we needed to anchor this cable net to the walls. And the first sketches, you can see here the first ideas and the first calculations. And well, and also it is very important, according to my opinion, to identify the main problems. Wind was a very important problem, and the second one were the anchorages of the cables in the walls. So, as I said, when you have one idea, you need to think that you need to develop this idea a lot, and this is the second stage, because all the cables planes were not parallel, because we needed to situate these cables in such a way to hang all the panels at least in 4 points. And well, we started thinking how to install the panels, how to install the top cables and bottom cables, and how to anchor. And you, as you can see, you doing many different proposals, you are able to develop your ideas. In some cases, you are not able to find the solution, so you have to go back and to start again. This was not the case, but we needed really to make efforts to really develop the idea. So this is important for me. I am the founder of FECOR, and I started my activity when I was 25 years old, and now I am the oldest. And I have, so I was young, like everyone, and now I really like to work with young people, and it is very important that we need to find a good approach to be efficient working together. This is the subject of another seminar. And yes, and this guy was able to use Grasshopper and was able to use many things. And from the first ideas, he was able to immediately, not immediately, but develop step by step a good model, which was very important because the geometry was very complicated, and we needed these tools to be able to estimate better our first estimations. And here you see how you can control the forces in the cables if you have a previous estimation of those forces, and how you can contribute to the to be able to prepare the model. So I think we have a very important activity or a very important challenge to be able to use all these incredible tools, but at the same time we have to be aware that you need to have ideas to be able to check those ideas with models. And yes, we decided the material to build the panels, and the previous experience is always very important. We had the opportunity to design this fiber carbon pedestrian bridge, so we had some experience with this material, but it was interesting because we had not a lot of time. We had not very good tools to estimate the behavior of this material, and so we needed to make some tests. With this test, we needed to check to adjust the stiffness and the behavior of the panels, and after that we were able to develop some calculations in order to see the deformation of the different panels, because the different panels were hung in different points. So we needed to create a system or a procedure to be really build these panels, and finally we had the panels. Wind was another problem, and so we needed to fabricate this model in order to make some wind tunnel tests. The anchorages of the cables in the walls was another problem, because we had two different type of walls. This one was very well done with good materials, but the other one was not the same. Was very poor materials, and so we needed to really see the way to investigate how we needed to fabricate the plates, and in which point we needed to really introduce the anchors. And here you have that we needed to see the wall and to decide in which places we were able to anchor to obtain a good result. So the construction process, you have to have a good construction process, and here you see that we have the catenary and we have the loads, and we have the idea was to create a platform and to introduce install the cables, and after that to install the panels. And here you have the construction process defined in the drawings. I think the drawings are very important to transmit, to communicate with other people who needs to produce our ideas. I love nice and clear drawings, and here you have the sequence. We install the cables system on the floor, and then we anchor in one wall and in the second wall. And here you have the one cable installed, and here we were tensioning the system, and here you have all the cables, the platform, the installation of the panels, and the final results. For me, all this process was very interesting for many reasons, but one of the important things is to see how, in which different way we are working. Architects are very used to use models like this one. Artists are very used to have models, but their models are one by one. So I had the opportunity to check the shape of my catenaries because they wanted really to build the model inside the shop of the artist, and this is amazing. And see here, you see that we installed the sculpture a little bit earlier, and we had the opportunity to make some corrections. And we normally use sketches like this one, and in some cases, sophisticated models. at the moment more and more. So we need to think on that because it is very interesting. This is another example. This is another example. This was a competition in Norway. We went to this competition together with Olav Olsen and Okau architects and another consulting which was involved in the geotechnical studies. Yes, in this case, my reflection is the following. Now you are able to reach different places with Google, signed Google, I call Google. You can identify the place of your project. You can go closer and closer. Yes, and this is very important because this allows you to start thinking. In this case, we needed to span a length of 125 meters, and for this length, without any pier in the river, you have many different possibilities, and we start making proposals and sketches. But here again, the previous experience is very important in arches, for example. But one day I decided to go to Norway. It was a very cold day, as you can see here. But this was really important for the decision we did because we, after visiting the place, after getting the human scale of the project, you are able to know much better which is the right solution according to your opinion to a given problem. And after the visit of the site, we started working immediately in the stress ribbon solution. One of the problems you have in this type of bridges is that the slope is variable because this kind of structure is very flexible, and yes, and in order to avoid big slopes, our idea was to introduce to make different depth of in the panels you install over the cables, and you see some sketches in which you can see that the segments which were close to the abutment were thinner, and the segments which were near to the middle span were thicker, and you have the possibility to start working in the details, the abutment, and always you have good inspirations. We were not inventing nothing because here you can see that the cables are following shape, and the pedestrian way is in another level. So so we use this idea, and it is very important at that in this kind of projects to analyze all the different details to see the feasibility. And when you work with architects, you see that they really want to create models, and this is one of the differences I was trying to make you evident in the last presentation. So at the end, we presented this proposal. The concept was the concept I tried to explain, and unfortunately we won the competition, but the pedestrian bridge was not built. And this is another example with other characteristics. At the moment, we need to deal with existing structures, And when you need to design something with the existing structures, you need to evaluate the situation of the existing structures. And this is a bridge which was built in the north of Spain in the 80s. The design was very accurate, and the authorities wanted to increase the width of the platform from 12 to 24 meters. And well, in those cases, you need to find all the available information, and this is not so easy because you need really to understand the existing structure. You need all the information will be at the end of the day very important. You can make tests, and you need to be clever to minimize those tests and to maximize the efficiency of the information you are receiving. You can measure, for example, the covers, but you need some additional models to be able to take into account the variability, for example, of the covers. And at the end of the day, with a lot of uncertainties, I have to say, you are able to have an estimation of the remaining service life of the structure, and you could, supported with this information, you can decide if you are able to use this existing structure. This is not an easy task, and it is clear that we in FIB at the moment are concentrated in trying to give good models to try to estimate, evaluate, assess the existing structure, and this is not so easy, but we are trying to do our best. Another classical problem of this kind of projects is that you need to maintain the traffic in the bridge or in the building or the use in the building when you you are building your intervention, because you can see here the road is here, the yellow one, and the alternative is a very long way, impossible for trucks and for heavy traffic. So this is very important. And again, you need to start. Our first idea was to create some other elements to expand the 150 meters of the span, but due to different, with using concrete or steel solutions, but at the end of the day, we decided to do something completely different. We had the idea to, and this was a key problem, to minimize the weight of the solution, and we made the widening of the slab, the top slab, with a lightweight concrete. We supported this new part of the deck with the struts, and the struts were putting all the loads in this new web. So we had a new web to be able to resist the new loads, shear of the new loads. We have this concrete and this bottom element, which was continue along all the bridge, which could work in tension or in compression. For that reason, this element was filled with concrete, high strength concrete, and with this we were able to stabilize the plates and to minimize the quantity of steel, and at the same time to make use of the concrete under compression. And finally, in order to solve the problems of the torsion, the new torsion, we decided to put longitudinal pre-stressing. The longitudinal pre-stressing was not very efficient to uplift the bridge, because you can see that the layout is very plain, and but we were introducing some compression in order to improve the behavior of the cross-section for torsion. And here you have a better explanation, but the concept is exactly the same. And here you have probably the concept represented in a nice way, and you can understand which was the solution. And but another important point is this one: we needed to create, to think how to build that bridge. And this is very important for me, because engineers have to go from the conception to the end of the construction. We have to be protagonists of this process, and we needed to create a country to install the steel elements underneath the existing cross-section. Here you have some pictures. You will be able in the later to see more in detail. And we needed to create another gantry to manage the demolition of the handovers of the bridge. And we need to develop another gantry to install the struts and to pour the concrete in the extension of the decks. So this is the final result, and I think it is important to know that we need to take into account many different aspects when you have to design an intervention in an existing structure. And finally, I will not present this one, and I will go to the conclusions. I really believe that we always have the possibility to create. We always have the possibility to enjoy creating, and this is very important. When you start, you will never stop, and this is also a real situation. And we have to be ambitious, to have the energy to fight and to work hard. Otherwise, it's impossible to develop a new idea, good and new ideas. To be humble, to learn every time about everything, because we need a wide culture, not only in our field, in every field, in order to be able to introduce this also in our work and do conceptual design. I don't want to finish without saying that this is the team of FECOR, and it is impossible to show all these projects without a team like this. Thank you so much.